Hello students, welcome to lecture series of Mathematics 1. I am Hitesh Manglani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss topic that is length of plane curves and area of surface of solid of revolution of chapter application of integration. So first of all, we will discuss about length of plane curves. So length of arc in Cartesian form. So the length of arc of curve y equal to f of x between x equal to a and x equal to b is given by s is equal to integration from a to b, then square root of 1 plus dy by dx whole square dx. Now we will discuss about length of arc in parametric form. So the length of the arc of the curve between the points t equal to t1 and t equal to t2 is given by s is equal to integration from t1 to t2 square root of dx divided by dt whole square plus dy divided by dt whole square dt. Now we will discuss length of arc in polar form. So the length of the arc of the curve r equal to f of theta between the points theta equal to theta 1 and theta equal to theta 2 is given by s is equal to integration from theta 1 to theta 2 square root of r square plus dr divided by d theta whole square d theta. So we will apply these formulas in examples. So let us discuss first example, that is find the length of the arc of the curve y is equal to log sec x from x equal to 0 to x equal to pi by 3. So here curve is y equal to log sec x. So first of all we will find out dy by dx. So that means we will have to take derivative of y with respect to x. So we know that derivative of log x is 1 divided by x. Therefore derivative of log sec x will be 1 divided by sec x. Then we will have to take derivative of sec x. So derivative of sec x is sec x into tan x. So this is sec x into tan x. And here sec x cancel out. So it will be tan x. Therefore dy by dx is equal to tan x. Now for the required arc, x varies from 0 to pi by 3. Because here we will have to find the length of arc of the curve y equal to log sec x from x equal to 0 to x equal to pi by 3. Therefore here x varies from 0 to pi by 3. Length of arc s is equal to integration from 0 to pi by 3 square root of 1 plus dy by dx whole square dx. So here this will be integration from 0 to pi by 3 square root of 1 plus tan square x dx, because dy by dx is tan x. Now we know that 1 plus tan square x is sec square x and square root of sec square x will be sec x. So this will be integration from 0 to pi by 3 sec x dx. Now here we will have to take integration of sec x. So we know that integration of sec x is log sec x plus tan x. So this will be log sec x plus tan x and limit will be from 0 to pi by 3. Now first of all we will replace x by pi by 3, then minus we will replace x by 0. So this will be log sec pi by 3 plus tan pi by 3, then minus log sec 0 plus tan 0. So here value of sec pi by 3 is 2 and value of tan pi by 3 is root 3 and value of sec 0 is 1 and tan 0 is 0. So minus log 1 and value of log 1 is 0. So this will be log 2 plus root 3. Therefore length of arc of the curve y equal to log sec x is log 2 plus root 3. Now we will discuss area of surface of solid of revolution. So first of all, we will discuss area of surface of solid of revolution in Cartesian form. So area of surface generated by revolving the arc of the curve y equal to f of x about the x-axis is given by s is equal to integration from a to b 2 pi y square root of 1 plus dy by dx whole square dx. Similarly, the area of the surface generated by revolving the arc of the curve x equal to f of y about the y-axis is given by s is equal to integration from c to d 2 pi x square root of 1 plus dx by dy whole square dy. Now we will discuss area of surface of solid of revolution in parametric form. So when the equation of the curve is given in parametric form, x equal to f1t and y equal to f2t with t1 less or equal to t less or equal to t2, then the area of surface of solid of revolution about the x-axis is given by s equal to integration from t1 to t2 2 pi y square root of dx by dt whole square plus dy by dt whole square dt. Now we will discuss area of surface of solid of revolution in polar form. So for the curve r equal to f of theta bounded between the radii vectors theta equal to theta 1 and theta equal to theta 2, the area of surface of the solid of revolution about the initial line theta equal to 0 is given by s is equal to integration from theta 1 to theta 2 2 pi r sin theta square root of r square plus dr by d theta whole square d theta. So we will apply these formulas in example. So let us discuss example related to this. Find the area of the surface of revolution generated by revolving the curve x equal to y cube from y equal to 0 to y equal to 2. So here given curve is x equal to y cube. So first of all we will find out dx by dy. That means we will have to take derivative of x with respect to y. So here derivative of y cube with respect to y will be 3y square, because we know that derivative of y raised to n with respect to y will be n into y raised to n minus 1. So by that formula dx by dy is equal to 3y square. Now we will draw the graph of curve x equal to y cube. So this is the graph of the curve x equal to y cube. Here this is the point A whose coordinates are 8, 2, and this is point O whose coordinates will be 0, 0. And we will have to find the area of surface of revolution generated by revolving the curve x equal to y cube from y equal to 0 to y equal to 2. Therefore, here limit of y will be from y equal to 0 to y equal to 2. This is y equal to 0 line because x-axis represents y equal to 0 line, and this is y equal to 2 line. So limit of y will be from y equal to 0 to y equal to 2. Therefore, the area of the surface is generated by revolving the region about the y-axis. So here we will have to revolve the region about y-axis. So for the region shown, y varies from 0 to 2. Therefore, surface area S is equal to integration from 0 to 2 pi x square root of 1 plus dx divided by dy whole square dy. Now here x is y cube, so this will be integration from 0 to 2 pi y cube square root of 1 plus 3y square whole square dy, because we have found earlier dx by dy is 3y square. Now here we will multiply this by 36 and divide by 36. So here it will be 2 pi divided by 36, integration from 0 to 2, 1 plus 9y raised to 4, because 3y square whole square. So it will be 9y raised to 4 whole raised to 1 by 2 36y cube dy. Here we have multiplied and divided by 36 because here if we take derivative of this function, then here derivative of 1 will be 0 and here derivative of y raised to 4 will be 4y cube. So 9 into 4, so 36y cube. Therefore here it will be 36y cube. So this will be pi divided by 18, 1 plus 9y raised to 4 whole raised to 3 by 2 divided by 3 by 2 and limit will be from 0 to 2. Because here we have used the formula integration of fy raised to n into f dash y dy is equal to fy raised to n plus 1 whole divided by n plus 1. So here this is the function of y and this is f dash y. So here first of all we will replace y by 2, then minus we will replace y by 0. Now here if we simplify this, then here it will be pi divided by 18 into 2 divided by 3. So it will be 2 pi divided by 54 into 145 raised to 3 by 2 minus 1. So if we simplify this, then it will be pi divided by 27, 145 square root of 145 minus 1, because 145 raised to 3 by 2 can be written as 145 into square root of 145. So this is the surface area. So in today's lecture, we have discussed about length of plane curves and area of surface of solid of revolution. Thank you for watching this lecture. I will see you in the next lecture.